are nerves. So the way they help us see, taste, everything is just generation of action potential. It's the same nerves, but the reason they're called special senses is because the neurons, the shape. You remember you classify neurons according to shape. You have the unipolar neuron. Unipolar neuron are just the sensory neurons. The bipolar neurons are only found in your special sense organs. And then the receptors are only found in the head region. So I think that's why they devote a special chapter to your special to these special senses. Again, how do they function? It's the same thing: generate action potential. Okay, and so here are your special senses. You have your olfaction, which is smell, taste or gustation. You have vision. You have hearing and equilibrium, and that's it. So olfaction is for these two, olfaction and taste. They are chemical sensations. You taste and you smell chemicals. So in other words, the receptors are called chemoreceptors. Okay? And then here for hearing, it's called mechanoreceptor. For vision, of course, you know they're called photoreceptors. So again, smell and taste, chemoreceptors; hearing, mechanoreceptors; vision, photoreceptors. Hearing and equilibrium actually. So let's look at the first, which is smell, olfaction. So how do you smell? You smell through your nose, right? And look at, this is where we put our finger. Your olfactory epithelium is all the way up there. If you remember the cribriform plate right there. You have the openings, that's the olfactory foramen, and you look under there. So the olfactory epithelium is all the way in there. That's why if you want to smell something, don't you go, you really want to, you want that smell to go all the way to the olfactory epithelium, which is up there. Your last lecture. Oh, first of all, let's prepare for your lecture test. By the way, on Thursday is your lecture test. Just so you remember. Oh, that's not your book. So, chapter 12 and 13. The reason why we include chapter 12, because chapter 12 is where you see the spinal cord. So we begin with the spinal cord for your lecture test on Thursday. Where's this? Right here. So this is a different, you have the, I'll use the new, I'll go here right here. So the new edition. We're done with the brain. So your test on Thursday will begin with 12.10, the spinal cord, page 465. You remember I told you you should be familiar with how the spine, a transection of the spinal cord looks like. And so if you look at 12.31, you need to know the dorsal root, the ventral root, the different structures here, right? The ventral gray horn, dorsal gray horn. And then remember in the thoracic spinal cord, you have the lateral gray horn. That's the only section of the spinal cord that will have the lateral gray horn, where your the autonomic neurons come out of, okay, innervating your internal organs. Then 12.11, the pathways. So figure 12.32, you have your ascending pathways. You need to be able to point out a first order, second order, third order neuron. Look at the first order is the receptor, right? The second order crosses over, and the third order begins in the thalamus to go to the somatosensory cortex. Then, and the different pathways, posterior column, spinothalamic, and what sensations go through there, remember? And then your descending pathways right here, 12.33, upper motor neuron, which decussates, and the lower motor neuron, which goes to the effector organ. The difference between flaccid paralysis, spastic paralysis. Then you go to chapter 13. The receptors, now we connect the dots. We start with receptors, so you should be familiar with the chemoreceptor, photoreceptor, etc., etc. Then you go the pathways. See, 13.2 receptors, ascending pathways, and then cerebral cortex, they process the sensory information. So you start with the receptor, and then the pathways, then the cortex, then you go down, then you respond. Okay? And then the reflexes. Oh, first the plexuses for the spinal nerves, right? It's a fusion of the ventral ramus, cervical plexus, brachial plexus, sacral plexus, and lumbar. I forgot lumbar first, then sacral plexus, and then the reflexes, which involves, at the very least, you have a sensory and a motor, but you can have an Remember the classification of reflex? The spinal reflex, cranial reflex, your monosynaptic, polysynaptic, ipsilateral, contralateral, intersegmental reflex, which we don't have a nice picture in this book, but you have it on your PowerPoint. Okay, so begin your study with chapter 12, spinal cord, all the way to chapter 13. And expect the same thing that you had just the last exam where there was some clinical cases, right? And then you figure out what do you think is the problem. So that will be uh, the same style, okay? Which you will have a lot of when you go to Bio 242. It's a lot of clinical thinking. Okay? So hopefully that will help you in your lecture test on Thursday. So now we go back to our special sense organs, the olfaction. So by the way, the chemicals we detect are called odorants. They're called odorants. That's why you apply deodorant. Where's it? Odorants. Odorants. That's why you apply deodorants, okay? So let's look at this one first. Where you find your neurons, the first order, right? The receptors. The location of your receptors for smell is in what you call olfactory epithelium. Isn't this epithelium? Okay. Your smell and your taste are unique as compared to all the other neurons in the body. They are part of an epithelium. And because they're exposed, do you agree? They are prone to damage all the time. And that's exactly what happens. They get damaged all the time, your neurons, your chemoreceptors for smell and for taste. So that's why within this olfactory epithelium, you will find this other cell called stem cells. You'll find basal cell. See? These are stem cells that can become receptor cells. They will replace these ones that get injured. So it is true for all neurons that they cannot divide anymore. Okay? Don't forget that. They will just be replaced by new ones. Okay? Just put it. Thank you. Okay? You understand? Okay, so this one, can this divide? No, neurons cannot divide. But the good news about your nose and the smell, the taste is you have stem cells there that can replace those that get injured. Okay, because they're exposed. And what helps these odorants to be trapped here are secretions from this gland called the Bowman's gland. Okay, so within your epithelium, you have a gland that secretes mucus. And the mucus helps trap the chemicals. When you inhale it, it gets trapped here, giving your receptors time to process, to be depolarized, generate action potential so you can smell. You understand? B for boogers also. That's why we have boogers, because they get trapped. The chemicals get trapped there. Okay? So now that we know the anatomy of our receptors there, how do we... Now, by the way, this one, this is the reason why you have this conky. This conky in your, you remember the superior, the middle, and the inferior conky? It creates turbulence and it slows down the speed of the air gives it time to mingle right here, be concentrated here, and generate action potential. Now let's look at how it smells. So what cranial nerve? Cranial nerve number one, right? So there's the chemicals, it's called odorants, generate action potential right here. Then synapse, this is called the olfactory bulb, which begins the pathway. And where is the smell going to go? Remember, nose and ears make a letter T, so it goes to your temporal lobe. Remember that. Nose and ears make a letter T, going to the temporal lobe. The last lecture test, not this coming Thursday, but your last lecture test is combined chapter 14 and 15. For chapter 15, usually in the past test, there were pictures like this. And so you either show me where the receptors are, or you need to remember olfactory epithelium. You need to remember where it's going to go. So this is the temporal lobe. Remember, your ears and then your nose. In addition to going to the temporal lobe, there's also a pathway that goes to the limbic lobe. What is the function of the limbic lobe? It is your memory, right? So that's why when you smell something, I think the book uses the example of your apple pie or chocolate chip cookies. You smell and it brings back memories because you store memories from what you smell. You store it in your limbic lobe, and that's why you also know. You smell, you say, "Oh, I smell chicken," or "I smell cookies," because you remember how it smelled and it's right there in your memory, or you associate certain memories to that one. Like my Baba, he likes to, he always buys the same, what is it for guys? Cologne? Perfume. Cologne. Because he wants, that's his signature. When you smell it, it's him. Or even with mothers, right? The babies, they smell you. They know that mommy's here because they have that memory. Okay? So we're done with smell. By the way, the loss of smell is called anosmia. Smell and taste are one of those sensations because it's epithelium and it constantly divides. After a while, you know that the rate of cell division slows down as we age. And that's why you notice with old people, you will notice that they need to spray more cologne or more because they can't smell anymore. Even with the taste, they over salt or over season the food because they can't taste anymore. It's just a part of getting old. Okay? Now we go to taste. You have any question on smell? Very easy. Don't forget, where is it going to go? Temporal lobe and limbic lobe. Now we go to taste, gustation, another chemical sense. So what do you call the receptors for taste? Chemoreceptors. What do you call the receptors for smell? Chemoreceptors. They're the same. Okay? They're the same. I remember there was a question, something like that. They're the same. In the type of stimulus that they respond to, they're the same. They respond to a chemical stimulus. Okay? So as far as taste is concerned, I know you're familiar with these different types of taste: sweet, salty, sour, bitter, etc., etc. Where are your taste receptors located? They're located in what you call, so the taste receptors are located in taste buds. That's where you find them. Where are the taste buds found? So this is your tongue. So the taste buds, I'm going to use the other one, right here. If you stick out your tongue, you see that there's a roughness to it. Okay? And so I'm going to use this one. So this is the view of the tongue. So this is your eyes, this is your nose, there's your tongue. Yes?
I'm not.
Huh?
I'm not. I asked him if they made one. I'm sorry.
Oh, okay. So here you go. There's your tongue, and this is the view of this one. Okay? This is the view of the tongue. It's like this, you're sticking it out. So you see, when you look at it, when you stick out your tongue, there's a roughness. And this is how the roughness looks like. You see where your taste buds are. They're embedded right there, deep in the recesses of your papilla. So the protrusions or the roughness is called a papilla. You understand? You stick out your tongue, it's rough. That roughness, it's like bumps, it's called papilla. And the taste buds are not on top. They're right there embedded in the recesses of the papilla. They're called lingual papilla. So you have different types of papilla. And I'm going to go back to this other slide. You understand so far? My taste buds, see, there's my taste buds. They're not on top, but right there. Which makes sense, right? Sometimes we eat hot soup or very cold ice. If they're all on top, they're all constantly going to be damaged. For this, if it's there, it's at least, you're able to protect it somehow. Okay? So the papilla are called right here in the back of your tongue, like an inverted V. This is called circumvallate papilla. Right here, the most predominant one is called fungiform papilla. Look at the shape of these two papilla. The circumvallate and the fungiform. These two papilla contain the taste buds. See, very nice dome shape. There is another papilla called filiform papilla. How do I try to remember? Like a nail file, pointy. This one has no taste buds. What is the function of this one? It's for friction, to keep the food in your tongue, giving it time for the taste buds, the receptors, to monitor, to be depolarized. You understand? You keep it there for friction. Otherwise, it will slip off, or you very easy to move about. You need to depolarize the neurons right here. Okay? So this one has no taste buds. And there's another group of papilla called the folate papilla, which is right here on the sides. A lot of books don't even include that because the folate papilla, they degenerate. They're only very active during childhood. So, let's look at atypical taste bud. This is atypical taste bud. You see, it's the same. It's epithelium, isn't it? And the cells, there's the receptor cells. This is the one that responds to the taste chemicals. And you notice there's stem cells there again. You see, the stem cells will replace this one, the receptors, because they are prone to being damaged. It's exposed. Epithelium has an exposed surface. Even though they're hidden right there, there's still an exposed surface. Okay? Now let's look at how we taste. So in the lecture test, the last lecture test, a lot of times there's a picture of the tongue like this. And you will be asked to name the 3 cranial nerves for taste and point to the area of the tongue that they monitor, their area of coverage. So the 3 cranial nerves for taste, 7, 9, and 10. So these 3 cranial nerves, see, cranial nerve number 7 serves the anterior 2/3 of the tongue. So you're just going to put a bracket like that, cranial nerve number 7. Then the posterior 1/3 is cranial nerve number 9 property. And then the rest is cranial nerve number 10. Those are the nerves that help us taste. You have your sweet, salty, sour, bitter, umami, and water sensation. You know that there's good water, there's bad water. And it's not until after you drink or swallow that water that you taste that water, because it's in they have different areas. The sweet and salty is in the front, anterior 2/3. So you can detect which cranial nerve is affected by just figuring out which of those sensations have you lost your taste for, or I know you remember how to test for those different cranial nerves, right? So the common complaint, if there's any injury to this or this, is loss of taste. Another common complaint is dry mouth, because saliva, the secretion of saliva from your salivary glands, is because of stimulation from these three cranial nerves. So they will complain of dry mouth and bad breath also, because the saliva has baking soda, not bicarb, bicarb, that neutralizes the acid pH in your mouth. Because it neutralizes that, you don't have dry mouth. Bad breath. Okay? So how do you test for cranial nerve number 7? You remember? It is responsible for facial expression. So you say, can you smile? Yes. And you look for symmetry. Very nice man. Okay. How about cranial nerve number 9? Gag. Right? You gag reflex. So you do that one. And then cranial nerve number 10 is your voice box. V for voice box. So you say to the patient, open your mouth and say, and then you look for that uvula. Remember? So that's how you taste. And then where is this going to go? Where is your taste cortex? It's in the parietal lobe and the insula. When it goes to the parietal lobe and the insula, that's when you finally say, I taste something. In addition to that, it also has collaterals that goes to the limbic lobe. So brings back memories. That's why some people don't like the taste of milk, maybe. Or don't like the taste of, because there's bad memories that you associate with it. I don't like milk because of bad memories. You see, I hate milk. My daughter doesn't want to use the word. Yes.
So when people like they drink and they like remember the smell and then they like gag, is that why?
Yes. You remember it. You just don't like it. Yes. Okay. You have any questions on taste and smell? Smell. So the chemicals for taste are called tastants. The chemicals for smell are called odorants. Tastants, odorants. So what type of receptors for taste and smell? Chemoreceptors. Okay. You should know where it goes. Okay. Smell goes to temporal lobe. Taste goes to parietal lobe and insula. Then what cranial nerve? Now we're going to go to vision. So we're just going to study the first half so you can do your dissection. We're going to open up the eye. So this is the eyeball. Vision is referred to as the dominant sense. You know that you can't really appreciate what you're eating. Even if it tastes so good, you want to see it. It's all coordinated. And that's why they say that if you lose your vision, you may go through depression. It's just very hard. Can you imagine? One day you can't see anymore. It must be so depressing. But because it is so important in coordinating all the sensations, it has to be protected. And so there are structures, see, that protect the eyeball. Let's look at these accessory structures first. Right here. So the eyelids, all the palpebra, right? So when you close your eyes, there's no opening. When you open your eyes, there's an opening. So this space right here is called fissure, palpebral fissure. That's where you see your eyeball. Okay? So the opening is the palpebral fissure. You know how fissure? So this part, this is called the fissure. palpebral fissure. Okay? And when you close, you don't see your eyeball. You open it, there's your eyeball. So this upper eyelid is called superior palpebra. This lower eyelid is called inferior palpebra. And you know that when you pull your eyelid under is what you call the conjunctiva. Are you familiar with the conjunctiva? Okay? So the conjunctiva is under your eyelid, the pink structure, right? Under superior conjunctiva, inferior conjunctiva.
So that was the reason that they call it conjunctivitis?
Yes. Okay? When the conjunctiva is pink, conjunctivitis. Okay? We're gonna talk about that. Okay, now first let's look at the other structures. These are your eyelashes, right? This is your eyebrows. Is there a function to the eyebrows and the eyelashes? Yes. You know when it's too hot, you go under the shade, right? So the eyebrows is like the shade for the eye, like a shade, protected from UV damage. And wherever there's hair, you know that there's sebaceous glands. We know that there's bacteria on our skin all the time. And wherever there's sebaceous secretion, the pH becomes acidic and it prevents bacteria from possibly causing any damage and entering there, even here. But because you have sebaceous glands, the secretion can be infected. So, you heard of sty?
Mm-hmm.
So, this, you see this one? You know that I just want you to know the difference, okay? There's two conditions. One is called sty and the other one is calasia. So, sty and calasia. So you have glands, sebaceous glands right here by your eyelashes, and that can be infected, and you see it like a nodule that's right there at the edge of the eyelid. The proper term, the proper diagnosis for that is called sty. Now you will see some patients like this one, like this. You see this one right here? You see them, right? It's like it's not on the eyelid. If it's on the eyelid, you say sty. Sometimes you see there's a redness. It's just right there. But it's red and it's painful. Because there's glands. There's conjunctival glands. It's called tarsal glands right there. That also has secretion. It secretes mucus. The secretion is very important to keep your eye moist. You know that the moisture is very important. It facilitates vision. The reason we see is because the light waves are bent. It's called refraction. You know what refraction means? Refraction means bending of light waves. The light waves, where's my eyeball? The light waves so you're seeing a lot. There's a lot of light, right? And they have to be bent and focused right at the center. So all the light waves, if this is your eyeball, all the light waves have to be focused at the center, a central spot, the central fovea. And so you know that fluid bends. I know you've done that experiment in high school where you put a straw and you look at it and the straw is bent, right? Where there's the water and the air interface, you look at the straw, it's like it's bent. And that's the importance of these secretions. They led to the bending of the light waves so you can focus properly. If the light waves are not all focused, some of them are spread, you won't be able to see properly. It's like it's blurry vision. So that's why you need secretions from them. Besides, these cells we're going to talk about, the eyeball is made up of cells, and so they have metabolic waste products. So they need to be drained constantly, and that's the purpose of the secretions. Okay, so you see the difference. You understand chalasia versus style. Okay, the other accessory organ that we're going to talk about are the muscles that move. No, not the lacrimal glands, that make tears. So on the superior lateral aspect of your eye, on each eye, you have the lacrimal gland right here. And you see, just by gravity, they make your tears, and it just drips by gravity. And it's very important for us to blink, because blinking is like a windshield washer that spreads the tears. So there's even a moistness that spread around, because dry eyes is going to compromise vision. You understand? And then it drains. See? It drains through this canal going to your nose. But sometimes overproduction of tears, when you cry, it starts spilling out here and maybe even in your nose, because there's too much. So now you understand the importance of tears. Besides, tears also contain antibodies, IgA, immunoglobulin A, and lysozyme, which have antibacterial properties. Okay? Then the other accessory organ that is very important in vision are your extrinsic eye muscles. So these extrinsic eye muscles move your eyeball in every direction that you can ever think of. There are three nerves that move the muscles of the eyeball: 3, 4, and 6. So you see, superior oblique is by cranial nerve number 4. Lateral rectus is cranial nerve number 6, and everything else is innervated by cranial nerve number 3. And without these muscles, what is this? Skeletal or cardiac or smooth? Skeletal muscle. So they're voluntary. In my opinion, this lateral rectus is the healthiest muscle in guys, right? Because they don't want to be obvious to their girlfriends or their wives, so they see someone, so they just move their eye like that without being obvious to their loved one that they're looking at someone else. Okay, so but that's if they get injured, you won't be able to move your eyeball. That problem is cross-eye. You've heard of diplopia? You've heard of this one? That just means you're cross-eyed.
And that's from just those muscles are not working.
Yeah,
They
yes.
just will fall forward.
Yes. Any of this actually will make you cross-eyed.
What about the lazy eye? That's the same thing.
The lazy eye is just the lazy eye. It's not really cross-eyed. It's just lazy. It won't move, right? So there's no paralysis. It just won't. It's just lazy.
Is it not?
And I think that's why they patch the healthy eye to force this to move. It's just lazy.
Well, another thing with the lazy eyes is you can get a contacts or glasses, and it'll actually strengthen those muscles so you can move.
With
Yes.
even the kids.
Oh, really?
Yeah,
Yeah, I seen some kids they patch this
Yeah.
one.
yeah.
Yeah, there's glasses.
Yeah, I had a worker. He said anytime he either gets tired or takes his glasses off, you could tell he has a lazy eye. But I didn't know he had one because he always wears glasses until he took his glasses off, and then it started.
I don't know why it becomes lazy. That's funny. Okay, so now we go to the actual eyeball. This is your eyeball. And it's called a ball because it's an actual ball. Okay, it's closed. They just open this so that they show us, we see what's inside. So when we're going to open up our not cat eye, that's a cow eye. You're going to see that it's a closed ball. Okay, and there are 3 layers that makes up your eyeball. Right here. So the outer layer is called the tunica fibrosa, or you just say outer layer or fibrous layer. Then you can say middle layer. The middle layer is the vascular layer. Another term is the tunica uvea or tunica vasculosa. And I'm sure you know the inner layer. You're familiar with retina. That's the innermost layer. Okay. So outer is vascular, very fibrous. Outer is fibrous, middle is vascular, and then inner is nervous layer, the retina. Let's look at them, study them one by one. So the outermost layer, this one, the fibrous layer, is made up of two parts. See? The sclera, which is the white part, and then the anterior part, the clear part, this one, is the cornea. You see where the cornea is? Where you see your donut, the color, this is the iris. Where you see the iris, that is the boundary of the cornea. Then everything else, the white part is the sclera. Let's look at the function. What's the function of the sclera? This is tough connective tissue. This protects your eyeball. This is the one that sits on the orbit right here. And you know that this is bone, very hard. So the sclera, you will see in the eyeball that it's generally covered by a fat pad, orbital fat pad it's called, to prevent pain right here, okay? The sclera is also the point for insertion of the muscles that move the eyeball. Your lateral rectus, superior oblique, inferior oblique, they're all right here. The sclera is also a vascular. It can supply blood to your inner layers. Okay. Now we go to the anterior part of your fibrous layer, which is your cornea. You're going to write that the cornea is the most sensitive part of the eye. It has a lot of free nerve endings. Okay, lots of free nerve endings, and it makes sense. I think that's a blessing. Can you imagine if you don't feel anything, someone will be poking you and sticking something you don't even feel, you're going to go blind. But it's very sensitive. Write down also that the sclera is avascular. It has no blood supply at all. That's why corneal transplants are one of the most successful surgeries. There's no way for antibodies to go there to reject. If you have a foreign cornea being transplanted, you can't reject it. There's no blood that goes there, okay? And the function of the cornea is for refraction. This cornea accomplishes 75% of the refraction of light waves. What does refraction mean again? Bending of light waves. So you can focus, yes.
Wait, so are both the sclera and the cornea avascular? Or-
No, the sclera is vascular.
Okay.
The cornea is not. Did I say sclera?
Yeah.
No, the cornea is avascular. I meant cornea. Sorry. We're just talking about the function of the cornea. This is avascular. This is for bending. Some people with no, there's a roughness called astigmatism. So this should be smooth. But some people, there's like a roughness and it affects their vision. So you can correct that with glasses.
You said the back pad that's underneath the cushion
Right
of
here?
our eyeball. Is that where our bags come from? Like,
No. The bags come from cucumber. I don't know. The eye bags, it's also because of the loss of elasticity here, collagen and elastic fibers. After a while, it's part of getting old. You're still young. Okay, next. So, correction, okay? This is sclera, this is cornea, this is avascular, this is vascular, okay? What else was the correction? That's it?
That's it.
Okay, now we go to the middle layer, which is your vascular layer also. This one is very vascular. So, of the three layers the sclera and the cornea is complete. It closes the eyeball. Then you go to the middle layer. You see there's a hole. So it's incomplete now. Okay? And there's three parts that make up the middle layer of the eye. You have the pupil, which is the donut. The pupil. Oh, sorry. The pupil is the opening. The iris. Then the ciliary body right here. And then this is the choroid. The larger posterior part is the choroid. One thing you will notice about this middle layer, it's colorful. Not colorful. Pigmented. Pigmented.
So which part do we actually see out of?
See out of. What do you mean see out of?
So like the pigmented area? No.
No. It would be the most inner layer. It would be the nervosa.
You see through your retina. So this one right here, this iris, what the iris does is controls the opening. The opening is called the pupil. We're studying the function of the iris now. This one controls the amount of light that enters your eyeball. You see because of the light waves that's being bounced off of the object that you want to see. And those light waves have to enter your retina, reach your retina, the neurons right here. The neurons are the ones that generate action potential. So the neurons actually will convert the light waves to visual sensation. Just like your taste, the taste is converted to a sensation that goes to the brain. The same thing here. Does it make sense? So you see out of your retina. The function of these structures we're studying is to control the amount of light. If there's too much light, you can't see. It's going to be blurry. So because you need light to see. But the function of this is to control the amount of light. And even this one, the opening is called pupil. This is called iris. Don't forget in the test, if it's pinned here, this is iris. And then the opening is called blank. Students always forget the pupil. Okay? So the opening is called the pupil. So the function of the iris is it controls the amount of light. By what? What if there's bright, constrict, right? And if it's dark, dilate. So what is the tissue type of the iris? Very good. It's muscle. It's smooth muscle. Okay? Yes.
I actually had a question on that. The color of
The
iris? Does the color also determine the amount of light that is absorbed? Like you have darker eyes, so you would absorb, dark absorbs more or less?
You can see better.
Absorb more.
Yeah.
That's not really.
It
Not
becomes
really.
blocked anyways. So
Yes.
It's
But
just
that's a very good.
It's
Observation.
really hard for me to see at night, and I have lighter eyes. I can't absorb as much light, but during the day I can see perfect. My
Maybe vitamin A. Did you ever check for vitamin A? Because that's what, if you can't see at night, that's called night blindness.
I have glasses, but even then it's like my dad has it too,
Oh, okay.
so it might be night blindness.
Maybe. Why don't you check for vitamin A levels?
I will.
Vitamin A is the one. We're going to talk about how we see. But maybe if there's too much, but it's not really. If you can't see at night, then it's not really the melanin pigments that makes
it's
you.
the rods.
It's the rods and the cones. That's very good. And it's the vitamin A in the rods and the cones that help us see. The function of this the melanin pigments do not make us see. The melanin pigments just control stray light. They absorb stray light, right? What does melanin pigment do? It protects us from UV damage. Same thing here. If there's too much light, it can damage your structures inside, mainly your neurons. So that's why the one characteristic of all this whole second layer all of this second layer, it's pigmented. You will see that when we open up the eyeball. All of this second layer from the iris, the ciliary body, all the way to this choroid, all of it is pigmented. Lots of melanin pigments to absorb stray light and to protect your cells from UV damage. And so that's why this first part of the second layer, the iris, it controls the amount of light. In addition to controlling the amount of the pigments absorb straight out, and the pigments is all the way to the second layer. You understand, okay? So this one, the iris is made up of smooth muscle. Your final exam's coming up soon. So don't forget your 4 basic tissue types: epithelium, connective, muscle, and nervous tissue. And in the final exam, wrong is wrong. So if there's a question, let's say, what is the basic tissue type of the iris? Someone will write smooth. That's wrong. The answer is muscle. So if you wrote smooth, that's marked wrong. Okay? Just so you know. So you need to remember, you need to memorize that, the 4 basic tissue types: epithelium, connective, muscle, nervous tissue. Those are the only correct answers. Okay? So look at this one. Look at your iris. It's made up of inner circular and outer longitudinal muscles. So when there's too much light, it constricts. And when there's not enough light, it dilates. That's smooth muscle. Now, we go to the second part, the second member of your tunica vasculosa, which is the ciliary body right here. So there's your iris right here. This is your iris. Then we're moving. This is your ciliary body. So the ciliary body, you see this one in the center, this is the lens right here. The lens. The function of the lens is also for refraction. So the cornea, 75% of refraction happens here, and the other 25% is because of your lens. Okay? And it's right there in the center. What keeps it, suspends it in the center is because of your ciliary body. From the ciliary body, you have suspensory ligaments that suspend this iris. And this one, these two, the ligaments and the iris. The iris, you know, why do I keep saying lens? Sorry. This is your lens suspended by these ligaments. You know that the lens, when you're young, like you, it's able to adjust, right? It's responsible for refraction. You heard of nearsightedness, myopia. So this one is able, of all the structures that's important for refraction, this one you cannot adjust, right? The cornea. Now I'm getting paranoid. This is cornea. Okay, my word. This is, you cannot change this. You cannot change the other shape. This one you can change the lens. So it can become rounder or flatter, depending. So when you're nearer, this eyeball, not eyeball, the lens should become rounder. So let's look at refraction. In the last test, in my previous test, there was a picture like this. You should be familiar with the lens, the function of the lens. So if you're normal, if you're 20/20, you are emmetropic. So emmetropia is normal vision, meaning the lens is able to bend the light waves right there in the center. You can see 20/20. But some people are nearsighted. That's called myopia, meaning you have to move the object closer to you so you can focus. So look at the problem of myopia. The light waves are prematurely converged ahead of the retina or in front of the retina. So some people with this one, they have long eyeballs. It's oblong, so they have to wear eyeglasses. The correcting eyeglasses is a concave lens which diverges. So you have to diverge the light waves. So concave is also referred to as diverging lens. You diverge the light waves, so then it will eventually end up in the retina, so you can see. Okay? So in the lecture test, I usually will have a picture like this, and you point to which one is emetropia, myopia, and then hyperopia. The hyperopia of old age is called presbyopia. So hyperopia and presbyopia are the same, except this presbyopia naturally happens as we get old. We will all get farsighted as we get old. Then you start buying the reading glasses, like me. Okay? So look at people who are hyperopic. See, the light waves, they overshoot the eyeball. So you have to move it far so you can see. How do you correct that? You converge the lenses. So you see a converging lens, which is convex in shape, will then properly refract the light waves so you can see. You understand? So don't forget, this, usually I ask this in the test so that you remember. Now, that's one function of the ciliary body. It suspends the lens, and you know now what the lens does, okay? Another function of the ciliary body, okay, is it makes aqueous humor. Aqueous humor. So you see that there are two chambers right here. This is the anterior and this is the posterior. Do you agree that, so the innermost part of the eyeball is the retina, that's neurons. And you see they collect, so this is all neurons. And you see, so the axons, all the axons collect of all these millions of neurons. No, there's actually 1 million. All of the axons collect and escape, or not escape, leave the eyeball to become the optic nerve. Okay? This neurons right here, the retina is purely neuron. They depend on the choroid for blood supply, for nutrition. You understand? Okay? So in other words, the retina and your choroid should be always touching each other. Okay? So the shape of your eyeball has to always be maintained. And that's the function of these two fluids here. The fluid here in the posterior chamber is called vitreous humor. This is gel-like inconsistency. And this one is permanent. You can't change that. You're born with that one. The ciliary body makes the fluid here called aqueous humor. So that's what's being made by the ciliary body right there. This is watery, more liquid. This is more jelly-like. This is more liquid-like. And the function of the aqueous humor is to drain. It's like power washing. You know that you have cells here. You know that they have metabolic waste products. And so the waste have to be drained away. So how do you wash them away? Aqueous humor. So this one makes the aqueous humor and it drains back like that. You see this opening here? That's called the canal of Schlemm. So it drains through the canal of Schlemm to go to venous circulation, go to your heart, and if it's any waste, you pee it out. Okay? And sometimes that canal can get blocked. Maybe if you're hypertensive or maybe idiopathic, it can get blocked. And then comes if it's blocked, that's dangerous, isn't it? That condition is called glaucoma. Don't you think that that's dangerous? If there's no way to drain out, in the meantime, it keeps making aqueous humor. That's very dangerous, right? One of the symptoms is extreme headache, pain right here, and burning. Like you feel like smoke coming out, it's just burning.
That's the clouding, right? That's cataract.
Yeah.
Oh, that is.
Clouding is cataract.
So
Glaucoma
that
is
when
increased
pressure?
pressure. Yes, the pressure. That's why when you go for eye exam, they do that pressure check, intraocular pressure, to make sure that it's normal. Because this is dangerous. It can lead to blindness. Can you picture how it can lead to blindness? Because this can be squeezed, right? You flatten, you can squeeze that retina because this is retina, and if there's increased pressure, you can flatten the neurons. They won't remember the shape of a cell is important to its function, right? So if you flatten that, you can be blind. And that's why it's an emergency. The other condition is retinal detachment. This one is when it gets detached. So look at, do you agree that, yes,
Is the glaucoma found in because of aqueous humor or vitreous?
aqueous. Vitreous is permanent. You cannot increase or decrease the vitreous humor, okay? Only the aqueous humor. So, you agree, right? That the shape of the eyeball has, and you will see. Once, don't forget what we're going to study now when you see the eyeball. This retina has to be flat and nice and smooth, right? But you will see once we open up the, because we're going to cut it open, what will happen. You will see that the retina all of a sudden will wrinkle because the fluid came out. Okay? So the retina can detach also. Can be because of maybe it was punctured, your eyeball. There's a pressure in there, right? And if it gets punctured, the pressure comes out. The retina is just like a piece of paper that's stuck in there, and if there's no more fluid that pushes it against, and then it just comes out. It detaches, retina detachment. Can also be from trauma, like severe head trauma, it can detach. Do you agree when I say that? Oh no, you tell me. Which one do you think is more dangerous? Immediate danger.
Retinal detachment.
Detachment, very good. With glaucoma, you're just changing the shape, but this one is already detached.
So you can't read.
Because
Yeah,
I was
it's
listening to a radio where the guy just, throwing lots of, he got elbowed in the eye playing basketball, and then he's got a detached retina, and then, but he was still at work and it just gone.
because you still have one. You have another one. But this one, you detach the retina. Remember, retina, that's your nerves. So if you don't immediately take care of that, you can go blind permanently. Okay?
Another thing was this year, my eyesight improved a
Is
lot. It improved. Like I always had a certain bad eyesight, and it went up by like a whole point. And does that mean my eyeball got less? The doctor said I have pointy eyeballs.
Pointed eyeball.
Pointy, like they're steep, and so that's why I don't see well. But then it's better now. Like it's getting better as I get older. It's just I don't understand.
Did they give you any? What do you mean you see better now?
Because okay, so I was at 3.5 vision, and then now it is at 2.5, and that's better for my prescription on contacts.
Oh, so you have contacts.
And it got better by a whole point. And I've always had the same prescription since I was 9.
Maybe the shape just changed. Maybe you're just the diet. Your diet now is much better. Maybe it's all diet, water. Remember, this is aqueous humor. This is vitreous humor. And what is the composition of your? Remember, to be able to see, to be able to see is a function of this and this. So what's that mainly? That's protein. And of course the water here and here, this is jello. This one you can change. So maybe this one, you have a problem with this one before. But I predict your problem was this one because you're taking contacts. not taking. You're using contacts. So maybe your problem was this before. It was a lazy lens. I don't know. But it's protein. That's crystalline lens. Crystalline protein.
Lazy eye
Just
also.
say thank you that you're seeing much better.
Right.
Now, the third part of the vascular layer is your choroid. This choroid, one thing, this is lots and lots of blood vessels. And one thing you will notice about the choroid is it's very, very, very pigmented. So this yellow one right here, this is actually black. Lots and lots of melanin pigments here. You see? See, in addition to your iris here, pigment, melanin pigments, all around, lots of melanin pigments. What's the function of the melanin? Absorb stray light. Any stray light will be absorbed because you won't be able to see clearly. Okay? And has lots of blood supply to nourish the innermost retina. Okay? Now we go to the innermost layer, which is the retina. Are you following so far? So this is the retina. There's your sclera, there's the cornea, which closes the whole eyeball. Then you go to the middle layer. This is the choroid, the ciliary body, and then your iris right there. And then the innermost layer right here is the retina. You see this blue? And you see the blue comes out to become your optic nerve. You see that one? So the retina and this retina, they just cut a portion of that. This is all the blue part. They didn't even cut the uvea or the sclera. Just the blue part, the retina. This is how it looks like. It's just all neurons. See? And the neurons, and at the base of it, so this is the one that's touching the uvea, the choroid. So there's a basal layer of, guess what? This is called pigment, again, pigment epithelium. You see how there's so many melanin pigments to absorb all of that stray light. So the retina is mainly neurons that lays on a bed of epithelium. This epithelium is called pigment epithelium, which contains melanin pigments. And another important function of this pigment epithelium is it stores vitamin A. You see because you have vitamin A. If you're lacking in vitamin A, you will have problems seeing. It is the vitamin A actually inside the photoreceptors that let you see. If you're deficient in vitamin A, you can't see. And the first symptom is night blindness. Very difficult for you to see at night. But actually, you're also having problems during the day, but it's only because during the day you have the cones that help you see, so you don't really notice. But both of them are affected by vitamin A deficiency. We're going to talk about physiology of vision on Thursday. After your lecture test, we're going to finish up this one. So take a break. But before you take a break, take out one sheet of paper, write your name.